All right, let's dive in. We're witnessing a massive shift in what AI is and what it can do. For a long time, we've thought of AI as this passive thing, right? You ask it a question, it gives you an answer. You tell it to write some text, it generates it. But that's all changing. We are moving from an AI that just predicts the next word to a whole new kind of software that can actually and autonomously solve problems.
So, what's the real difference here? Well, on one side, you've got the AI we're all pretty familiar with, predictive AI. It's totally passive. You have to feed it prompts and guide it every single step of the way. But on the other side, we have autonomous agents, and these are active. You don't give them a step-by-step prompt, you give them a goal, and then they go off and figure out all the necessary steps on their own. And believe me, this is a total game changer.
So how in the world do they pull this off? Let's get into the anatomy of an AI agent. Honestly, the easiest way to wrap your head around its architecture is to think of it like a person, made up of three absolutely essential parts.
Okay, first up, every single agent has a model. You can just think of this as its brain. This is that core language model, like a Gemini or another big foundation model, that does all the heavy lifting, all the reasoning. It's the part that processes information, weighs all the different options, and at the end of the day, makes the decisions. It's the thinker. But a brain isn't very useful if it can't actually interact with the world around it. And that's exactly where tools come in. These are the agent's hands. Tools are what connect the agent's thinking to the real world, letting it take actual actions. We're talking calling a search API, digging into a database, or even writing and running its own code. This is how an agent gets stuff done.
And finally, we've got the orchestration layer. If the model is the brain and tools are the hands, then this is the agent's nervous system. It's the process that connects the brain to the hands and runs the whole show. It manages the agent's entire cycle of operations, handling the planning, remembering what it's already done, and deciding, okay, should I think more about this, or is it time to use a tool?
So we have our brain, our hands, and our nervous system. Let's take a look at how an agent actually thinks by breaking down its operational loop. It's basically a non-stop cycle of problem solving. An agent is always working inside this loop. It starts with a mission from you, the user. Then it just cycles through thinking, acting, and observing, over and over again. It pulls in context, it comes up with a plan, it uses its tools to take an action, and then, this is the key part, it observes the result of that action. It feeds that new information right back into the loop to decide what to do next. And it just keeps going through this think, act, observe cycle until that mission is complete.
And this brings us to a really critical idea. The real magic of an agent isn't just that it can think. It's about its ability to manage what it's thinking about at any given moment. It's constantly curating its context window, which you can basically think of as its short-term memory. It's deciding what information from its tools or from you is the most important piece of the puzzle for the very next step. This smart management of its own attention is what lets it tackle really complex problems. Now, just like people, not all agents are built the same. We can actually classify them based on what they can do, using a fun little analogy we're calling the agent career ladder. Let's watch how they climb the rungs, from a total intern to a real innovator. Right at the bottom of the ladder, we have our level 1 agent. This is the first big step up, where that core reasoning engine, the brain, finally gets hooked up to tools that let it touch the real world. So a level 1 agent can now use tools. Think of it like an intern who can suddenly use the internet instead of just relying on what's in their old textbooks. A basic language model knows all about the history of the Yankees, for sure, but it has no idea what the score was last night, because that happened after it was trained. A level 1 agent, though, it can figure that out. It recognizes it needs fresh info, it uses a search tool to find the score, and it gives you the right answer. The next rung up the ladder is level 2. And this is a serious promotion. This is where the agent goes beyond just simple one-shot tasks and starts to strategically plan how to achieve complex multi-part goals. The crucial difference here is planning. A level 1 agent can find me a coffee shop. Easy. But what if you ask it to find a good coffee shop halfway between my office and my client's office? Whoa. That needs a multi-step plan. A level 2 agent can reason, okay, first I need to find the halfway point, then I'll search for highly rated coffee shops in that exact area. It's actively building its own context to solve the problem step by step. At level 3, the whole way of thinking changes. Instead of trying to build one single, all-powerful super agent that can do everything, we start to mirror how a human organization works, with a team of specialists all working together. And this is where it gets really, really cool.
Imagine a project manager agent gets a mission: launch our new headphones. It doesn't even try to do all the work itself. Nope, it starts delegating. It gives a task to a specialized market research agent to check out the competition. It tells the web dev agent to build the product web page. It's treating other, more focused agents as its tools, orchestrating an entire complex business workflow.
And finally, at the very top of the career ladder, we get to level 4. This is maybe the most profound leap yet, moving from just delegating tasks to autonomously creating and adapting on its own. Let's go back to our project manager agent launching those headphones. What happens if it realizes it needs to monitor social media for what people are saying, but there's no tool or agent on its team that can do that? A level 4 system doesn't just fail. It identifies that gap in its own abilities and then acts to fill it. It might use a high-level tool to literally build a brand new sentiment analysis agent on the spot. It's a system that can grow and expand its own skill set.
Okay, this all sounds incredibly powerful, and, well, it is. But there is a massive difference between a cool demo on a laptop and a tough production-grade system that a real business can actually count on. So how do we get from here to there? And this is the billion-dollar question, isn't it? It's one thing to build a prototype that works sometimes. It's a whole other challenge to make sure these autonomous systems are secure, reliable, and high quality enough for the real world. You have to remember, every bit of power we give an agent also introduces a new bit of risk. So, getting to production means we need a whole new set of rules. We need agent ops for managing and testing these sometimes unpredictable systems. We need agent identity, think of it like a digital passport for each agent, to control what it's allowed to do. We need governance to manage a whole fleet of these things without creating chaos. And finally, of course, we need really strong security guardrails to put hard limits on what an agent can and cannot do. When you put all of these pieces together, it becomes pretty clear that we're not just building better tools anymore. We are building a new kind of teammate. And this really gets to the core of it all. The job of a developer is fundamentally changing. We're shifting away from being bricklayers, where we had to write every single line of code and define every piece of logic. Instead, we're becoming directors. Our new job is to set the stage, give clear instructions, pick the right cast of tools, and provide the guidance to help these autonomous actors achieve the final goal. This whole transition from passive tools to active partners forces us to ask some pretty deep questions. We've looked at the building blocks, the career ladder, and the bumpy road to production, but this journey is really just getting started, and it leaves us with one final thought to chew on. What happens when our software can not only think, but can also learn, adapt, and create, all on its own?